Alright, welcome back everyone. I want to make a video here on all my headway and progress that I have been making over the past 2 years on all my electromagnetism work. This should be a very inspiring, educational, and um, uh, hopefully entertaining video. But there's not going to be many demonstrations in this one. This is just going to be going over some of the things I've already gone over in my other videos and some things that I may have not gone over. I'm going to try and go over as much as I can from start to finish here. Um, I'm not sure how long this video is going to be, but here we go. Um, I'm going to first start off with just how to make these stand-up lamps. They're pretty simple. Um, these stands I got from a camera. You know, you usually get these three-legged stands for a camera mount. I got this one for a little home camera that I have. And what I did was I took the brackets off of a motor like this. See these brackets here? See, this is what's on the rotor, on the inner part of the motor. So what I did is I took these two top and bottom pieces off, and I took a screw and screwed in through the top into the ends that connect to the fluorescent bulb, and I just ran the two cords. I actually took a thinner wire from an AC adapter so they could fit through these holes. The original wire actually was too big to fit through these holes, so I got a thinner wire and spliced it with the bigger wire, and it worked just fine. The size of the wire doesn't seem to really matter when it comes to individual lighting. But that's not what I wanted to go over. That was just the quickest thing to go over, was just how to make one of those. I'll post up another video after this one that shows the whole wiring process and everything with that, and the on and off switch. But what I really want to go over is everything that led me up to building my flywheel generator wheel, and how I've come to think now that and see, these are the coils that I used for my original prototype flywheel. This was my prototype right here. It goes on this little motor like that. And what I did with this one in a previous video is I took these coils with this thin wire, and they didn't have anything in the centers of them. They were hollow, and I had 6 of them just kind of duct taped and jerry-rigged around this wheel right here. And in that video I showed, by getting this thing going, that I could get 5 volts of DC, and if I didn't have it connected to that circuit diode that turned it into DC, it would have been 6 volts AC. I didn't show that in the video that I posted up earlier, but that's what it was. It was 6 volts AC, and I got 5 volts of DC once this got up to 60 hertz electric current. So at 60 hertz I could get 5 volts of DC and 6 volts of AC out of this tiny little wheel using these magnets right here. I had these magnets glued to the sides of these. So anyway, these were really strong, really powerful magnets, even stronger than the ones that are in microwaves, because I got these out of a hand crank generator. But continuing on, instead of having this thin wire, See, this wire is way too thin. See, it's amazing. I was able to get 5-6 volts out of these thin wire coils, and they had no iron cores in them. See, here's the iron cores that go in them. And if you take one of these and you just plug it in, the wire is so thin that it actually starts melting the coating that's over it. I plugged this one in, and within a few moments it started to melt and smoke. So when you plug thin wire directly into the outlet, it tends to cook the wire or fry the wire. But when I connect it to thicker wire like this, that's going through metal, nothing. It seems to be all right. So you don't want to connect thin wire directly to the wall that doesn't have any thick wire on there. So, well, if you connect just thin wire to the wall, it'll melt. But the way these ones are set up is it has going through the thin wire that's around this piece of metal, but it's also got this thicker wire up here that is also completing a circuit to whatever you're powering. So since this thick wire is here and it's connected to whatever you're powering, when you plug these things in, the thin wire doesn't melt because it's being distributed to a load that causes more resistance that makes it so the wire doesn't fry. But going into more detail here on how the thin and thick wires kind of interact is this is an inverter. It's an 800 watt power inverter that I just took apart, and what usually happens is you have these two connected to a 12 volt battery DC, and these thick wires, the positive the positive current comes in and it goes into the capacitors, loads of the capacitors, and then it starts discharging into these coils here that are wrapped in metal. There's a bunch of thin wires wrapped in these coils. I think there's 2 wires each wrapped in these coils, or maybe there's 3 wires each, because there's 6 diodes in here that change the direct current into an alternating current. And when it's in an alternating current, after this stage, these 6 diodes then send it to these other resistors that there's since there's 6 diodes for blocking the current in one direction, then there should be 10 little resistors each for each diode. So 10 little resistors for each diode would lag the current a little bit for each wire. So that would be 10 times 6, that would be 60. So there's 60 resistors, 6 diodes, a few capacitors, and a few coils here that all work together to take a DC load, change it into an alternating current load, and then use resistors to lag that load 60 times a second to get this 60 hertz current out. And if you notice that it's going from thick wire to thinner wire, the importance of the going from the thick wire to the thin wire, I can't remind everyone enough on how important I think that's starting to become, because this circuit board is kind of a good example. You see, this circuit board has just individual thick wires, and any circuit board that you look at, if you turn it over or see the side that has the soldering done, you'll notice that each connection, each soldering point only has a single wire in it, and that's what it's like for all circuit boards. Like every circuit board that has this kind of circuitry on it, they're all individual single wires that are going through the circuit board. The only time you have multiple wires is from the actual wire from the plug. See, so this is just a regular plug and a regular wire. This is the one plugs we use in America. We got positive and negative that alternate 60 times a second right there, and it comes out a bunch of little thin wires, and they're usually connected to something like this. One of these ends, or both of these ends, are connected to these two ends right here, and these two ends are connected to just one single thin copper wire, just one wire, and it winds around this piece of metal a bunch of times. Then it comes and connects with this one. There might be two wires. There might be one wrapped, and then it comes and connects with this, and then another wire comes and wraps, and it comes out here. So it might be two coils that are connected together by this middle soldering spot here, but basically it's just one thin wire wrapped a bunch of times around metal, and it comes out here, and it connects to the two other wires that get plugged into the wall. But these other wires that plug into the wall are a bunch of thin wires. So you could, they're basically a bunch of wires because, you want to be able to run multiple things in your home. So it's like, instead of having just one wire, one little thin wire going from the wall to the motor, they have a bunch of thin wires. And that, in my opinion, causes more resistance because these wires are loose. They're not even tight. You want these wires to be tight because the more tension you have, the less resistance, and the least amount of wires you have total gives less resistance too. So I think instead of plugging something in with just a bunch of thin wires, I'm going to attempt to, once I get this all mounted and all set up and ready to go, I'm going to try to use just individual thin wires and run them from the outlet to the two spots on the transformer, because this is just one wire. So I think that this should just be one wire, and everything that comes from the generator should just be one wire too. So it's going from a thick wire that's being, getting a north-south alternating current from the magnets going by, and that thick wire has the electrons going back and forth, but the two ends of the thick wire are then connected to two ends of a thin wire. So the amount of alternating electric current in the thick wire gets pushed into a thinner wire that increases the voltage. So that's the whole connection between increasing voltage after you get the generator going, is you have the thick wire on the coils around the flywheel getting alternating current from the magnets, just like how this one did in that one video. Once these things are flying by, you can feel the pushing and pulling. Like if I were to take a magnet and this thing's spinning really fast, and I take a magnet and go by here, I can feel it vibrating from the north-south going by real fast. And when you take a high-powered magnet and you go near an exposed wire, from a lamp like this, you can actually feel the same vibration. You can feel that north-south pulling and pushing effect from just the wire that's inducing electricity into a lamp. You can feel the same effect. And that's what I'm kind of shooting for when it comes to my flywheel generator wheel here. So I'm trying to get that push and pulling effect to get into a coil like this that has, an iron core. These are the little iron cores that came out of these coils, but it's going to be thick wire like this and then it has iron cores, and then they're going to be mounted to this board or zip tied to this board. And the flywheel I'll bring down in a moment and show you. I got the magnets zip tied to the sides of that. But you know, overall you can kind of see, you know, everything that gets used by electricity all has thin wire in it, unless you're stepping it down into a lower voltage, then they have the thicker wire in it like this. But but from the start, from the get-go, you want to have the thick wire wrapped around this metal or transformer. The two ends of that thick wire are going to be two coils that are around the flywheel. So there's going to be one coil here, you know, it's going to be wrapped, it's going to come around, wrapped in another coil here, and then the two ends are going to connect to the two thick ends of the transformer. And the thick wire that's going to get an alternating current is going to put a higher voltage into the thinner wire, and that's where you're going to get the higher voltage. It's out the thinner wire. Okay, so hopefully everybody kind of understands that. I'm going to be shooting for anywhere between 13 and 16 volts once I get this all mounted and put together. I'm going to go over my flywheel here. I had a couple of comments from my last posts that the bearing that I was using looked really good, or really smooth, and I'm trying to help people, just like Mr. Wangus is doing. You know, I want to try to help people, you know, understand this better so they can build one of their own. But you know, just keep in mind the this generator flywheel part of the construction is probably the most difficult part. I mean, this is where the current begins. This is where you generate current and begin to move it through the wires. So it's probably the most difficult part, because you need a flywheel with the least resistance as possible, and you have to have these magnets mounted to the edge of that wheel, and then you have to have these coils that are going to be mounted away from those magnets, and these coils are going to have highly magnetizable metal inside them. So these coils that are mounted away from the magnets are going to want to stick. I mean, the magnets and the coils are going to want to stick to one another, but because they're going to be mounted apart, they're not going to be able to. And because they're mounted apart, that's what induces the electricity through the wire. The iron cores and the coils are going to be inducing their magnetic fields as the magnets go by. So the copper wire that's wrapped around them is going to be inducing the same thing, the electronic current back and forth. So the higher magnetizable metal you have as a core, I think the stronger the current you can get, and the thicker the wire you have around the coil or around the core, the more amps and the stronger current you can get, more torque anyway. Okay, so going into the middle section of my flywheel bearing, my original one was just a little motor that didn't have any bearings at all, so it was able to get 6 volts with no bearings at all. But the one I'm using now doesn't have any. Well, it has ball bearings in it. Here they are, right here. See, there was originally, I think, two ball bearings for my wheel here. See, this is actually a magnet that's on a metal plate. It's actually magnetized to this metal plate, and this piece of metal right here and this piece of metal right here are actually a part of a record player. I don't know how many people out there spin records. I think there was only 2 of these bearings in there before, so I'm going to just put 2 in. See, what's going on here is these little ball bearings go inside this hole here, and this thing then it magnetizes the the ring magnet like somehow magnetizes the shaft that it's going to be sitting on. And it kind of, you know, because it's magnetizing the shaft that it's sitting on right in the middle, it kind of has this interesting floating effect. You know, it feels really smooth, and it just feels like there's no resistance hardly at all. You might be able to recognize it better if I do this. Let's see here. There we go. See, this was the original metal piece that goes on the top. This is what you usually see or find on record players. This usually plays a record. And when I first took it apart, I noticed that it worked really well as a centerpiece for my flywheel. But I'm not sure how many bearings it had in it originally, but the bearings on the inside here is what makes the friction so low, because these little bearings, they're like little spheres, and when you have something, you know, when you have these spheres stacked, you know, like 2 or 3 high like this, then the amount of surface area that you're, you know, getting on your shaft here is, you know, just it's a tiny amount by the, you know, tops and bottoms of the bearings that I'm using. I think this originally had 2 little ball bearings in it, and that's what it had originally, but I took apart just a regular, you know, skateboard bearing or regular ball bearing from whatever, you know, fan or whatever, and I put 3 ball bearings in here, and after putting 3, it sat up a little higher, and if you notice that when I spin it, the magnet's a little off. Huh. That's weird. I didn't do that before. Usually spun pretty freely. Maybe it needs a little oil or something. Let's see. It spun a lot better before. Yeah, see how well it spins with you know, with those, just the bearings stacked like that. See, instead of having you know, like skateboard wheel bearings or whatever, where you have a bunch of bearings in a circle, and there, you know, there's little metal rings that connect them. This is kind of simpler. It's kind of a simpler method. It has just very few ball bearings, and they're stacked on one another. And because they're stacked on one another, the amount of surface area is really low. Huh. Well, yeah, that's the way it was before. It was quiet like that. Yeah, see, it spins a lot better with 3 bearings. I don't know. I'm gonna have to put some drops of oil in there or something. But you know, as you can see, it definitely spins a lot better. And like that. Maybe I got the bearings in there, you know, wrong or something. Oh yeah, see, this is what magnets do, man. They stick to all these metals, so that's the tricky part in all this. You got to make these wheels and metals and coils and stuff where they're mounted apart. That's why in my last one that I had, everything was duct taped, so I didn't want to put these iron cores in the middle of my coils in that one video that I demonstrated. And ended up I have to put the camera down a second. Okay. Try and get these little bearings to work better. They were not working like this before. There we go. Yeah, well, you get the point. Instead of using ball bearings from wheels and skateboards and such, and just stack the bearings and use these record playing thing. It's just the way the magnet like magnetizes, and the way it floats is. Oh well, just a little oil will help with that. I got some. I'll put it on there in a little bit. Anyway, just kind of making sure I'm going over everything here. This was kind of interesting. I decided to take one of these fluorescent lamp things apart and look on the inner side here. And if you notice on the inside, there's a big capacitor right there. The two wires are actually individual thick wires. One's red and one's black right here. I'm not sure if this runs on DC or AC. Well, it takes in AC, but I'm not sure what the bulb itself actually runs on. Since there's a red and black wire, it looks like it might run on DC. The bulb stopped working when I took it apart, or it didn't work anymore, so I don't know. I tried to test it and nothing came on, so I just thought that was interesting. You know, even these little screw-in bulbs have tiny little circuit boards and little coils in them and such. I thought that was kind of cool. But overall, what I think is happening in all this is that you're taking magnets and a flywheel and individual thick wires. You know, these wires, or any wire that connects to the plug outlet, they have a bunch of thin wires in them. That's because when you're running stuff, you know, out of the wall, they got more than just one generator, you know, running all at a time. So just kind of think of all these wires as each individual wire is connected to coils that are connected to a generator. Like every two wires, you know, is another coil that's around a generator. So if you have if you got 20 wires, you know, 20 in each strand here. So then what you would have, you know, 40 coils or whatever. You know, you got two coils for each wire. So it's like, you know, instead of thinking of a bunch of little wires, you know, connected to a generator. Because I tried making a motor with a bunch of wires like this, you know, wrapping it around a piece of metal and trying to see if it worked, but it didn't. There was too much resistance because there was too many wires, and there was too many individual wires. But using just one individual wire is how these motors work. So it's only when you plug something in, it's only taking power from one of the wires, but all these wires, you know, wound together like this, you know, act as a thick wire, but have more resistance. If they were just individual thin wires, they would have less resistance and use less power to run, but those thin wires would be easily breakable. You know, these wires are very easily snapped in two, so it is better to have a bunch of wires like this when, you know, using a wire. But when it comes to efficiency on power generation and distribution and utilization, I'm starting to see that you want thick wire getting an alternating current from the flywheel magnets, and the two ends of the thick wire are going to end up being connected to the two ends of the thinner wire. And the two ends of the thinner wire is what gets the higher voltage from the thicker wire that's getting the electric alternating current from the north and south magnets going by. So north, south, you know, alternating north-south current, and thick wire, the thick wire connected to a little wire. So you can imagine all the electrons moving in a big thick wire, and then you connect it to these little thin wires, and the little thin wires gets, the thin wire gets more voltage, more current, because it's taking all the current from the thick wire and compressing it down into that thin wire, so you get a higher voltage. It makes sense in my mind, but it may take a few times to understand when first learning about that. I mean, I've been studying this stuff for 2 years, and I still feel like I don't hardly understand it all. Before I bring my flywheel down, I just wanted to pose a question for everyone. I want to use this DC motor to run the flywheel once it's up and going, but I'm not sure if I need just one diode or two. See, this diode's going to make the current only go in one direction, but I just wasn't sure if I needed two of these diodes, so it makes sure, even though the current's alternating as it's going into this, these diodes are going to make it so it only goes in one direction. I wasn't sure if I needed one on each end of the DC motor, or if I just needed one. Or if anybody knows, please hit me up. Give me a shout. Let me know what you think. And yeah, I'd be happy to hear your input and feedback on that, because I'm still not too sure until I get it all mounted and set up if it's gonna work better with two diodes or just one or whatever. So got my flywheel ready to put on here. Got all the magnets zip tied to the end. It's definitely a lot heavier than it was, and I only have one magnet on the edge for each position, as two. So I want to get three, like Mangus had on his. He had 3 magnets on each of his there, and I can only find one microwave at a time when looking for it in Isla Vista. I don't know how many people have heard of Isla Vista, but that's where I've been going to look for my recyclable junk for my free energy wheel here. But yeah, I got the magnets zip tied on here. Like I said in the last video, I'm going to be using 8 spots instead of 6. I had 6 originally, and like on this one only has 6 spots, but because this is a bigger wheel, and it just seems to work out better to have more spots. I wanted to have 9 because now Tesla was always referring to the number 3 or the number 9 when he was alive. He was fixated on the number 3, and he always did things in 3s or 9s. So I wanted to have 9, but I was only able to fit 8. So let's see. What I'm gonna have is these coils are gonna be, they're gonna be, put some blocks or something here, and they're gonna be mounted or zip tied to this board and away from the magnets like this. There's just enough room to be able to put 3 magnets here, and once 3 magnets are on there, that's all the room I'm going to have, or else the coil's going to start creeping off the board. And the DC motor goes here, like that. When it comes to trying to get the DC motor mounted here. Since it's narrower on these sides, I'm going to use these. I'm going to try to run something up and mount it to the DC motor and then run it to the other side over here, and hopefully still have enough room for these coils. So you can see about 3 magnets is going to be about here, and I'm going to have about that much room for something to come up and over and to connect to that and then come up and over, be mounted to the board. So hopefully that's going to take a while for me to get all finished and completed, so I'm not so sure how long it's going to be until I post up the video of everything all completed and mounted. But you know, just before I started mounting everything down and I had all the parts all kind of spread out like this, I just wanted to make this video to hopefully get the viewers to understand as well as I do what's going on here, how electricity is actually produced in the wire, how it gets to go, you know, back and forth, whatever. Because each one of these magnets, see, I got my little individual magnet here. I'll take this DC motor off here. Get these kind of farther away from the magnets so they don't have an influence. So let's see. It's not pressed down enough here. Yeah, see, I need to get this mounted better because it's going to be heavier once I get more magnets. Alright, how's that? It's still a little wobbly, but it should be alright. Alright, let's see how long it can go for. But if you ever get, you know, this much completed, you know, get magnets on the edge of a wheel like this, and you take another magnet and you bring it close, you know, don't let the magnet pull them together, but if you get it close like this, you can feel the vibrations from the magnets flying by, going do 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 do. You know, you can feel it pushing and pulling this magnet in my hand as they go by. And when I take a magnet to an exposed wire from one of my lamps, it feels like the same thing. It feels like the same exact force. I feel the... Anyway, see the magnet moving by itself? Let's speed this up one more time. Yeah, see the magnet wiggling? Well, the magnets react a lot stronger than the electrical current from the light, but if you get it close enough to a wire, it does the same thing. An exposed wire with electricity does the same thing that this wheel is doing to this magnet right now. Exposed wire to the same magnet will do the same shit. Okay, so this video is going on 40 minutes, so I'm going to stop it here. So hopefully, you know, this was educational, and it's kind of ironic because everything that I just kind of went over was pretty much everything I've learned in the last 2 years doing all this stuff, and to put it all in a short video like this is kind of I don't know what to feel, but it's just interesting because if I had somebody post up a video like this for me a couple years ago, it would have saved me a lot of time and a lot of trouble, a lot of effort, and a lot of, definitely saved me a lot of construction time of building, little prototypes like this and trying to get, make sure I can generate a small current. And, I was able to generate 5-6 volts with this little thing, so I was convinced that I could actually build a bigger one and get more voltage. But it was at such a low voltage, only 5-6 volts. I was like, how am I going to get it up to 120? And it wasn't until I started messing around with these little transformers that are in power adapters. They're in, these transformers are in power adapters like this. It's just they're wrapped in this black plastic, so you can't see the metal in the wires. But every one of these adapters that change alternating current into low voltage DC current all has these transformers in them. There's the original two from my demonstration in the last videos, so you can see how they work, and you can see in the other video how you can get low voltage from, these coils that I had were hollow too. There was no iron cores in them. These iron cores are going to make the current stronger. The iron cores are magnetizing and making the current go back and forth, just like the magnets make the current go back and forth in the copper. But the iron cores increase the amount of torque that you get in the wire. When I had them in that one video where they were hollow, I was only getting 5-6 volts. But now that they're going to have iron cores, I should get, hopefully at least double. So you can see I'm hoping to get at least 12 volts, 12 to 15 volts. But not until I get this all mounted and completed. It'll only be at that time that I'll know for sure how this is going to work. But I'm going to have these coils. I'm going to have 8 of them all mounted to the board with magnetized metal, thick, really thick wire like this wrapped around these. And I'm going to have one wire wrapped around one coil, one wire wrapped around, the same wire wrapped around another coil, and the two ends are going to connect to transformers, and the transformers are going to be connected to plugs. They're going to be connected to circuitry boards and motors and stuff. So okay, alright, so this is now going on 43 minutes, so I'm going to stop it here, and if I forgot something or anything like that, I'll post it up in another video. I'll post up another short video after this one to show how the wires connect with this. There's a little static electricity induction coil in here that connects between the power cord and the actual little circuit board that all those wires are connecting to. It'll be more clear in the video that I post after this. So anyway, thanks for watching. Sorry the video was so long, but I'm just trying to go over everything as well as I can to try to get this familiar with any of the viewers that they can build one, so they can build one themselves. If you watch Mangus's videos, Mr. Mangus Wangus, he uses these magnets out of microwaves, and I tried to use these magnets, but they were just, these ones can be zip tied, so it just makes it easier to mount them to the flywheel. These ones I couldn't. I tried taping them, I tried gluing them, and they just would not stay. Just like this, all jerry rigged and everything. So it just they need to be mounted to the wheel really well, and so does the coils and the metals in them, because those are going to be magnetizing. The magnets and the metals are going to want to stick together, and if they're not mounted apart well enough, you're gonna end up with problems. Things are going to go. When this thing's up to speed, and these things fail, and magnets start flying around metal and wire, it just would not be a good scene. So that's where I'm at. Hopefully it won't take me too much time to get this completed, but Thanks again for watching and stay tuned. Hopefully I'll get another video up soon.